one student at a school is now on campus. So viewers, today I am here with a new Maya. So our today's Maya topic is what fun trick I can learn with numbers or math. Post the session live on social media. So let's start. First of all, viewers call the Maya for some questions.
Hey, good morning. What's on your mind today?
Okay, so Maya, my first question for you is what's a simple math trick that can impress my friends? Please give me fully long answer and give me 100 points on it about this topic. And
Uh, we're gonna go. Sounds good. Talk soon. Hey there. Anything you're wanting to dive into today?
Maya, my question for you is what's a simple math trick that can impress my friends? Please give me a long answer about this topic and please give me very interesting answer and more about 100 points on this topic.
Right, sorry about that. You want to pull a fast one on your friends, huh? Okay. A classic that always gets a reaction is the 1089 trick. It's surprisingly simple, but looks super impressive. Here's how it works. 1. Tell your friend to pick any 3-digit number, as long as the first and last digits aren't the same. For example, they could pick 327. 2. Have them reverse the digits. So 327 becomes 723. 3. Tell them to subtract the smaller number from the larger number. In our example, that's 723, 327, 396. 4. Now tell them to reverse the digits of the result. So 396 becomes 693. Finally, ask them to add that reverse number to the original result. 396 plus 693. 1089. No matter what 3-digit number they start with, as long as the first and last digits aren't identical, they'll always end up with that 1089. Now, let's get into why this works. This is where the 100 points level detail comes in. It all comes down to a bit of algebraic manipulation. Let's represent your friend's 3-digit number as 100A plus 10B plus C, where A, trim, and C are the digits in the hundreds, tens, and ones places, respectively. When you reverse the digits, you get 100C plus 10B plus. Subtracting the smaller from the larger gives you so. The result of the subtraction is always a multiple of 99. Then you reverse the digits of this result, giving you 99 10. Adding that to the original difference gives 99 plus 99 plus 99 plus 99 plus 0, 0. Wait, that's not 1089. What went wrong? Well, there's one tiny little catch. The subtraction doesn't always result in a 3-digit number. If a C, then the result will have 3 digits that can be reversed easily. However, if CA, it will result in a negative number. We can show this in the following way. Because your friend's number has to have a different first and last digit, the answer must result in a remainder of 9, meaning if you add 999 to it, it must equal 199. So the number is 99 times the difference of the hundreds and ones digit plus 999. This translates to 99 decks, few 199, 1/6. It's a neat trick that elegantly showcases some basic algebraic principles without anyone needing to know the math behind it. It looks like you're performing some kind of mental wizardry. Give it a try and let me know how it goes. Hopefully your friend's impressed. Does that explanation hit the 100 points mark for you? Ah,
Okay.
everything all right?
It's really
You went
good
quiet there?
answer. I really
Just
appreciate you,
checking.
Maya. So, can you teach me a number guessing trick that feels like a magic? So, please give me fully long answer about this topic and give me 100 points on it. First point, explain one, two, three, four, like this. Okay.
Okay, glad you liked the last one. You want to feel like a proper mind reader, huh? All right, let's dive into a number guessing trick that's pretty convincing. This one relies on some clever binary math, but don't let that scare you. It's easier to explain than it sounds. Here's how it goes, broken down into points, as you asked one. First, tell your friend to think of a number between 1 and 15. It's important they keep it secret. This range is crucial for the trick to work. Two, now ask them to follow these instructions and tell you only yes or no after each one A. Is your number even? Is your number greater than 7? C. Is your number the result of adding 1 and 7? D. Is your number divisible by 3? 3. After they've answered yes or no to each question, you can reveal their number. Now let's break down the logic. This is where the 100 points explanation comes in. We're essentially using the answers to these questions as bits of information, like zeros and ones in binary code. Each question narrows down the possibilities. Let's map it out. Question 1. Is your number even? This divides the possibilities into even and odd numbers. Question 2. Is your number greater than 7? This further divides the numbers into those above and below 7. Question 3. Is your number the result of adding 1 and 7? This focuses on the number 8, a key divider to identify answers. Question 4. Is your number divisible by 3? This tests other ranges of divisibility to eliminate other possibilities. To reveal their number, here's how to interpret the responses. Assign each yes a value of 1 and each no a value of 0. If the answers are yes, yes, no, no, their number is 12. If the answers are yes, 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 their number is 14. If the answers are yes, no, no, their number is 2. If the answers are no, 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 their number is 1. And so on. You can create a truth table to map all 16 possibilities in their answers. It sounds complicated written out, but once you have the table, it becomes very straightforward. I won't write out the full table here because it's quite long, but you can find them online easily if you search for mind reading number trick binary. The key is to know the table beforehand and quickly translate their answers into the correct number. It's not actual mind reading, of course, but it will certainly seem that way to your friends. The illusion is powerful because it feels tailored to their specific choice, even though it's a deterministic algorithm. Do you want me to walk through a specific example with sample answers? Or would you like to know where you can find a complete truth table online to have handy? Does that all make sense? Still there? Just wanted to check in.
Okay, Maya,
Sometimes
it's really good answer. I really appreciate you for this one. So, how my next question for you is how can I make someone think I read their mind using numbers, and what is the 1089 tricks and why does it always work? So, please give me very interesting answer about this topic. Like a very good answer, and that's a good one answer. I really appreciate you for this answer. So, it's really a simple answer and very interesting answer. Okay, so let's start.
All right, you want to amp up the mind reading illusion, huh? Okay, let's dive into classic, a seemingly impossible number prediction trick. This one's known as the 21 card trick, but we'll simplify it to just numbers to make it easier for a quick mental play. It's deceptive because it feels completely random, yet it always works due to a clever mathematical principle. Here's how it goes, along with the 100 points explanation. 1. Tell your friend to think of a number between 1 and 10. 2. Ask them to double that number. 3. Tell them to add 8 to the result. Light of clue 2. Now, ask them to divide that sum by 2. Finally, ask them to subtract their original number from the answer. The result will always be 4. Now, the why this works is the interesting part. Let's break it down algebraically. Let's x be the original number your friend is thinking of. The steps translate to the following equation. Fun.I. Simplifying the equation gives x plus 4 dot x4. And as you can see, the x's cancel out, leaving you with 4. So no matter what number your friend starts with, the process mathematically forces the result to be 4. The perceived magic comes from the fact that these steps disguise the underlying math. Your friend doesn't see the equation, so it feels like you somehow guessed their final answer. It's a simple algebraic manipulation, cleverly disguised as a mental feat. Now, you asked about 29 tricks. Well, there aren't 29 variations of this exact trick. There are many number-based mentalism tricks that rely on similar principles of mathematical patterns and deception. Here's a quick rundown of some similar fun tricks. A 37 trick similar to the 21 card trick works with 37. The magic square, a 3x3 grid with a hidden pattern. Predicting a sum. Asking someone to think of multiple numbers and predict their sum. The birthday trick, using calendar calculations to reveal someone's birthday. These tricks all exploit hidden mathematical patterns or psychological principles to create the illusion of mind reading. They aren't about actual psychic ability, they're about clever manipulation of numbers and information. The effectiveness of these tricks relies on distraction, misdirection, and the human tendency to look for patterns where they might not exist. Do you want me to explain any of those other tricks in more detail? Perhaps we could walk through the steps of the 37 trick, as it's very similar in principle to the one we just discussed. Or are you happy with this explanation for now? Everything okay? You've been quiet for a bit. Just letting you know I'm here if you
Okay,
want to
so
continue the conversation
Maya,
or have another question.
hello, Maya. That's really great answer, and I really appreciate you for this answer. And can you show me a pattern in multiplication that looks magical? And what's the math behind the pick a number game? So please give very interesting answer and fully long answer about this topic. I'm waiting for your long and like interesting answer about this topic. So let's.
All right, you're on a roll with the illusions. You want some mathematical magic, and I'm happy to deliver. Let's tackle two things, a surprising multiplication pattern and the math behind the pick a number game. Get ready for a deep dive. I'm aiming for that very interesting and fully long answer you requested, the magical multiplication pattern, the 9 pattern. This is a classic that looks like genuine mind reading. Tell your friend to 1. Think of a number between 1 and 9. 2. Multiply it by 9. 3. Take the digits of the result and add them together. For Ponyfu, really vary Pete step 3 until they get to a single digit number. No matter what number they start with, they will always end up with 9. Let's break down the math. Any number multiplied by 9 will result in a multiple of 9. A key concept here is digital root. The digital root of a number is the single digit value you get by repeatedly adding the digits until you reach a single digit. Any multiple of 9 has a digital root of 9. Here's why. For example, let's say your friend picks 5 shid, 5 by 9, 45 man, 5 all former man, 6 6 7 63 6 6 4 3 9 and so on. The pattern holds. This relies on the properties of divisibility by 9. If a number is divisible by 9, the sum of its digits must also be divisible by 9. The pick a number game, math behind the magic. This is the one where you ask someone to think of a number, perform some operations, and then seemingly reveal their number. We've already touched on elements of this, but let's refine it into a more structured game and analyze the math. Here's a version of the game. 1. Tell your friend to pick a number. 2. Ask them to triple that number. 3. Tell them to add 6 to the result. 4. Ask them to divide that sum by 3. Tell them to subtract their original number from the answer. The result will always be 2. Now, let's break down the algebra. Let Cx be the original number. Triple the number 3x. 2. Add 6. 3x plus 6. Divide by 3. 3 plus 6. 3x plus 6. 3 plus 6. 3. The original number. 6 cancels out, leaving you with 2. This trick, like the others, works because of algebraic manipulation. The operations are carefully chosen to eliminate the original number and arrive at a predetermined result. It's a beautiful demonstration of how mathematical principles can create the illusion of mind reading. The power of these tricks lies in their simplicity and the unexpected nature of the result. People expect randomness, but they encounter predictable outcome. This creates a sense of wonder and reinforces the illusion of a magical ability. Does this answer meet your standards for length and detail? Would you like me to explain any part of this further or maybe tackle another mathematical trick? I'm happy to delve deeper into the world of numerical illusions. Still with me? Just checking in? Feel free to let me know if you want to switch gears or explore something else. No pressure at all.
Okay, Maya, that's really good one answer. I
Okay.
really appreciate you. So why do so many number tricks and end up the with same answer? And can you make a number game I can play with kids? What's a way to combine numbers and storytelling for fun? So please give a very interesting answer and fully long answer about this topic. I'm waiting for your long answer and very explanation answer because my viewers is very explanate on this.
All right, you want to pull back the curtain even further and understand the why behind the magic, and then create some magic of your own. Excellent. Let's tackle both those questions, the common results of number tricks, and then a fun number game with storytelling woven in. Prepare for a long one, as requested. Why do so many number tricks end up with the same answer? The reason so many number tricks converge on a specific result boils down to a few key mathematical principles. 1. Algebraic simplification. Most number tricks are built upon simple algebraic equations. Through a series of operations, addition, subtraction, multiplication, division, variables cancel each other out, leaving a constant value. We saw this clearly in the examples we just went through. The starting number effectively vanishes, leaving only the predetermined result. Modular arithmetic. This is a bit more advanced, but it explains patterns based on remainders. For example, many tricks involving multiples of 9 rely on the principle that any multiple of 9 has a digital root of 9. The specific operations chosen in the trick ensure that the final result falls into a predictable remainder category. 3. Properties of numbers. Certain numbers have inherent properties that lend themselves to trickery. For instance, the number 1089 is special because of its unique relationship to three-digit numbers and the rules of subtraction and addition we explored earlier. Clever manipulation. The trick isn't necessarily about the numbers themselves, but about how the operations are sequenced. The order of operations is crucial to ensure that the variables cancel out and the desired outcome is achieved. Essentially, these tricks aren't about predicting the unpredictable. They're about subtly guiding the process through a series of algebraic manipulations to arrive at a
Oh yeah,
predetermined
it's really
answer.
good answer
The illusion.
and really very interesting things about this world and this topic. So part two, fast thinking tricks, minutes 9:13 years old, and how can I multiply large numbers faster in my head, and what's the easiest trick for multiplying by 9, and how can I quickly square numbers in ending it over, in ending 5? Is there a trick mentally divide by 5 by 5 or 25? How do mathematicians and divide by of over 5 by 25? So please give me a very interesting answer and very meaningful answer about this topic. I'm waiting for your long answers. Let's start.
Okay, you're on a quest for mental math superpowers. Let's equip you with some fast thinking tricks tailored for a 13-year-old and then tackle those large number challenges. This is going to be a comprehensive response. Buckle up. Fast thinking tricks for a 13-year-old. These aren't just about speed, but about building number sense and confidence. 1. Left to right. Addition to subtraction. Instead of starting with the ones place, start with the largest place value. This helps you build a running total. Example, 345 plus, think 300 plus 200, 500, 40, 30, 70, 5 plus, result 576 to rounding and adjusting round numbers to the nearest 10 or 100 to make the calculation easier, then adjust. Example, 48 plus 23. Think. 50 plus
No, no, Maya,
20,
it's wrong
70.
answer. I think you that the 5 by 25. So 5 by 25 is on over an like 5 over 25. 5 5s are 25. So please give me a good one answer and a correct answer on it. So let's.
Subtract. My apologies. You are absolutely right to call me out on that. I completely misread your request and went off on a tangent about general fast thinking tricks instead of focusing on the specific quick calculations you asked about. That was a mistake on my part, and I apologize for the unhelpful response. I am still under development and learning to interpret requests accurately. Let's get this right. You want fast tricks for multiplying large numbers, multiplying by 9, squaring numbers ending in 5, and dividing by 5. Here we go, and I'll be much more focused this time. Fast mental math tricks 1. Multiplying large numbers. Faster. The key here is breaking down the numbers into manageable parts. Let's say you want to multiply 23 by 47. Think of it as 23 by 40 plus 23 by 7, 920 plus 161, 1081. Practice breaking numbers into easily multiplied components. Easiest trick for multiplying by 9. This is a classic. To multiply any number by 9, subtract 1 from the number and put that number to the left of the result. Example 9, 6 petit, 63, 7, 1, 6. So place a 6 to the left of 3. Example 9, 34, 3, 36, 34, 1, 33. So place a 6 to the right of 33. Squaring numbers ending in 5. This is a beautiful trick. Take the digits before the 5 and multiply them by 1 more than the.
Yeah, it's very good trick. But most important trick is to I want to explain you 43 or 45. It's wrong answer. So please give me a correct answer and like a very meaningful and mathematics answer related answer. So I want to make a cartoons on it like 1, 2, 3, 4 on this. So please guide me for some cartoons, AI cartoons. So please give me a very interesting answer about this topic. I'm waiting for your good one answer.
You are absolutely right to push back on that. I am deeply sorry. My explanation for squaring numbers ending in 5 was completely flawed and inaccurate. I'm still learning to consistently deliver correct mathematical explanations, and I clearly failed there. You are spot on to hold me accountable. Let's get to the correct way, and then I'll help you brainstorm a cartoon explanation. Squaring numbers ending in 5 the correct way. This is how it works, and it's beautiful. Take the digit or digits before the 5. 2. Multiply that number by the number 1 greater than itself. 3. Append 25 to the result. Let's break it down with example 1, 45 1. The number before the 5 is 4. 2. Multiply 4 by 5, 4 by 5, 20. Append 25, 2025. Therefore, 45 quadric or 2025. Example 2.
Okay, so this was our Maya. I hope you like it. I talked with Maya. I really appreciate this Maya for this session. So this was our Maya. I hope you like it. So I meet with you and next day, next topic. Thank you and I love this.